The first thing we need to talk about when talking about chemistry, when talking about organic chemistry, is what is an atom, right? We talk about this idea a lot in chemistry. Atoms are these very small, indivisible particles that we can combine together to make a whole myriad of compounds, molecules and compounds. All of the atoms are constructed in a similar way. They are constructed in an orderly fashion, and that order gives us the periodic table of elements. But when we talk about an atom, we need to really understand what it is and how it is constructed. So an atom is made up of three parts. It's made up of protons, neutrons, and electrons. And the atom nucleus is very small. The atom nucleus is less than 1% of the total volume of an individual atom. And inside that nucleus, we have protons and neutrons. Making up the vast majority of the volume of an atom is going to be the electron cloud. So out here, and not just out here, but from here all the way out to here, is filled with electrons moving around. Depending on the number of protons in an atom, depending on the number of neutrons in an atom, you are going to find that it's going to vary how many electrons are found in that atom. So when we talk about an individual atom, and we talk about the atomic number of the periodic table, an element such as hydrogen is going to be found as number 1 on the periodic table. That's going to have 1 proton. So the number of protons equals the element. So if we have 1 proton, that's going to be hydrogen. If we have 6 protons, that's going to be carbon. We're going to talk a lot about carbon in organic chemistry. And if we have something like 17 protons, we're going to get a molecule like chlorine. Now, within an individual element on the periodic table, such as hydrogen, you're going to find out that hydrogen doesn't have the mass of a single proton and a single electron if you look at the average molar mass on a periodic table. And that's because hydrogen is about 99%, greater than 99%, hydrogen 1, or H1, 1H. We're just going to refer to this as hydrogen. But a small amount, less than 1%, of hydrogen has both a proton and a neutron in it. And so we're going to call this deuterium. And if you come to my lab, I'll show you bottles of molecules, solutions that have a lot of deuterium atoms in them for specialized organic techniques that we use. So we're just going to call this hydrogen. And if you happen to go and build nuclear weapons for some country, a very small amount of when those nuclear weapons go off, you generate H3. It's a radioactive form of hydrogen called tritium. And if you have any tritium in your lab, the Department of Energy would like to know about it. And so all of these forms have exactly 1 proton. Hydrogen has no neutrons, deuterium has 1 neutron, and tritium has 2 neutrons. So the masses of those hydrogens are reported there. That's not all. Carbon also has a number of various elemental forms of it. All of these forms are known as isotopes. Isotopes are different varieties of elemental atoms. So there are 3 isotopes for hydrogen. There are also 3 isotopes for carbon. Carbon-12, the most common carbon, about 98%, has 6 protons plus 6 neutrons. Carbon-13, about 1% of all carbon in the world is carbon-13, also has 6 protons plus 7 neutrons. And carbon-14, a very unstable form of carbon. Carbon-14 doesn't live that long, so it's much, much less than 1%. Much less, not much greater. Carbon-14 is a radioactive isotope of carbon that has 6 protons and 8 neutrons. But carbon-14 very quickly converts into nitrogen by gaining another, by some sort of beta particle decay. And so carbon-14 will turn into nitrogen-14, which is the stablest isotope of nitrogen. And as a result, these isotopes here are the reason why we can do things like radio isotope labeling of, say, plants and see how long these plants are around. We know that various grasses, various plants go through a specific growing cycle. And something like corn uses a lot of C13. So you can actually find isotopes of C13 in your body because you consume a lot of corn or corn diet-based materials. If you drink sodas that have high fructose corn syrup, or if you eat a lot of agriculturally grown meats, chickens and cows, pig, they all have a lot of carbon in them because the vast majority of our diet is based on corn.